Our project is automatic window shade, which can adjust the position of the roller shades to keep the room at a certain brightness level. The brightness level can be preset by the user. The main objective of this project is to provide a more convenient way to take advantages of the sunlight and to save energy usage at home or public buildings. For example, I have seen some SJSU classes, they have the lights turned on while the window shades are completely rolled down. It is possibly because it is inconvenient to roll up and down the shades when people need more light for writing or need less light when using the projector. Therefore, we design an automatic window shades which will be able to roll up or down with the help of a motor and light sensor. The light sensor detects the brightness level and sends the signal to the FM4E board, which will make the motor drive the roller shades to the desired height. The light sensor will be placed inside the room, and it will monitor the brightness level of the room. The user will also be able to reset the desired brightness level anytime. Okay, so for the mechanical design, we have a roller shades held by two holders, this one and that one. These holders are mounted to the wall above the window. We also have a DC motor mounted to the left holder. The motor can drive the shaft of the roller and be able to roll it up and down when rotating in different direction. There's an opto interrupter installed at the top of the window to detect if the shade is completely rolled up. And there's also a refracted opto sensor at the bottom of the window to see if the shade is completely rolled down. For our electrical design, this is our schematic of the circuit setup. We have the feather board right in the middle. It is supplying 3.3 volt to a resistor and the photoresistor. Pin 80 is monitoring the voltage of the photoresistor. It reads higher voltage when there's more light fall onto the photoresistor. And pin D12, it's connected to the hex inverter, which will be responsible for changing the direction of the motor. Pin D13, it's connected to ENA on the driver board to activate the motor. Pin 11 connects with reflective opto sensor, which is in charge of detecting when the shades reach the bottom limit. We also have a opto interrupter connects with pin 10, and it detects the upper limit. Both of them are responsible for preventing over traveling of the window shades. On the right side, there's a motor drive board. We have 8 dry batteries to supply 12 volt to the driver board to activate the motor, which is also connected to the driver board. The 2 momentary switches protects the motor from over traveling. And finally, the pin USB, it's responsible for supplying 5 volt to the opto interrupter, reflected opto, hex inverter, and the driver board. So for the demo, Unfortunately, we were not able to finish the hardware assembly due to COVID-19 quarantine. All we can do is to create an animation in SolidWorks to show how our design works. At the initial position, the system will display the current brightness in terms of the voltage. Then it will ask the user to input a desired brightness. If the user input a value that is higher than the current brightness, the shades will roll up until the current brightness equals the desired value. Similarly, if the desired value is lower than the current brightness, the shades will roll down until the values are the same. If the roller shades reach bottom of the window, but the instant brightness is still higher than the desired value, the motor will stop to prevent over-traveling, and the system will show the user that it reaches the lower limit and will ask for a new input. The same function will be applied when the shades reach the top of the window. After setting a preferred brightness level, the window shades will automatically adjust the shade position while the brightness changes over time from morning to evening to provide a more convenient way to make good use of light and to improve light quality. Some future work could be finish up the assembly and test its sensitivity on the change of brightness. An additional design could be adding a smart light bulb that will turn on if the preferred brightness is lower than the brightness when the window is covered completely. And that pretty much concludes our project. Thanks for watching.